Assalamu alaikum, dear students. Some of the students are asking about symmetry worksheet. So we are doing this worksheet one by one. First question is all about fill in the blanks. It says that a square has dash lines of symmetry. First of all, we have to think that what a square shape is. A square shape is a shape which has all sides equal. So if it has all sides equal, then we can have one line of symmetry horizontal, one line of symmetry vertical, and the same happens in diagonals. One line of symmetry in diagonal and one line of symmetry and reverse diagonal. So there are one, two, three, and four lines of symmetry. So that's why its answer is it has four lines of symmetry. Now look at the second one. It says that an equilateral triangle has dashed lines of symmetry. What is equilateral triangle? An equilateral triangle is a triangle which has all sides equal. So if it has all sides equal, so it means if we have one line of symmetry here, second line of symmetry here, and then there is third line of symmetry here. So the equilateral triangle has three lines of symmetry. Now, a line of symmetry divides an image into dash equal halves. So if we'll be looking for any shape, let's suppose, for example, the rectangle, if I'm drawing a line of symmetry, is it dividing into how many halves? It is one half and two halves. So we'll say that it will be dividing into two equal halves. Now, question number 4, part 4 says a scalene triangle has dash lines of symmetry. So first of all, what is a scalene triangle? A scalene triangle is that type of triangle which have no lines equal. So all of them are of different sizes. So if this is a different size, so it will have no line of symmetry. If I'll be drawing a line here, it will not give a same shape on the either side. Similarly, if I'm drawing here, it will not give the same shape on the either side. So that's why if we'll be drawing any type of line and any side will not be having two equal sides. So that's why this says that it has no lines of symmetry. Or sometimes we can say that zero line of symmetry. Okay. Now a circle. Question number 5 says a circle has dashed lines of symmetry. So a circle, if we'll be drawing one line of symmetry here, so it will be crossing the center, dividing it in two. There's another line of symmetry, and then the third line of symmetry, and then the fourth line of symmetry, and then the fifth, and then the sixth, and then the seventh, and then the eighth, and ninth, and 10th, and 11th. So there is going on process. It will not end. So that's why we'll say that a circle has infinite line of symmetry. So this is the only shape which has infinite lines of symmetry. Similarly, the letter H has dash line of symmetry. So first of all, we have to draw H shape. This is H shape. And in this H shape, if we'll be drawing line of symmetry, there's one line of symmetry which is dividing H into two halves. Similarly, there's another line which is also dividing H into two halves is this horizontal line. So it means H has two lines of symmetry. Okay. Now, seventh part says a line is a dash of figure if it has the half shapes on the either side of the lines of congruent. So it is a line is an image of the figure. So we can say that this is actually the image of a figure if half shape on the either side of the line are congruent, or we can say that this is a Symmetrical shape as line is a dashed line of a figure if it has half shape on the either side of the line of congruence. Now, eighth part says a figure may have more than one line of symmetry, one more than one line of symmetry. A dash figure means the regular figure, any regular figure, because if the regular figure is there, regular figure means all sides are equal. If it is a square, it's a triangle, it's a pentagon, so it may have not one line of symmetry, it may have more than one line of symmetry. Okay, so now ninth point is a point is a dash of a figure if the figure maps onto itself, uh, onto the upon the rotation about the point. So a point is the center of rotation of a figure, because if it's the center of rotation, so it will be rotating about that point. So we'll say that this is a center of rotation. Center of rotation is a point where the figure is rotating itself into many places. So that's why this is called center of rotation. Like the fan, if there is a fan, we see that the fan is rotating at its one point. So that point is the center of rotation on which the fan is rotating itself. Now, the last point is that is the number of different ways in which the figure can map onto itself by rotation. It says the number of different ways. So the uh, angle of rotation is the order of rotation. It is the order of rotation is the number of different ways. Okay, order of rotation, because this is discuss about the rotation. So in the rotation, we see that if the line is there and we are going to rotate it, is it giving the same shape or not? So the number of times it's giving the same shape, it is called the order of that figure, order of rotation of that figure. So we'll be discussing this here in the questions. So we'll be discussing. Now look for the questions. Now it says that fill in the given table, mark the center of rotation. First, we have to mark the center of rotation. How will be drawing the center of rotation? We'll be drawing line from edges to edges and then second edge to second edge. So we see that these lines are crossing each other at some point. So the point where the lines are crossing is the central point. This central point is called the center of rotation. Similarly, here we are again doing the same pattern here, this one, and now I'm drawing one line here, this one, and then I'm drawing one line from the center, this one, and then I'm drawing another line from the center. So I see that there's one point is there, which is the center of these all lines, common for these all lines. This is the center of rotation. Similarly, the same happens with the equilateral triangle. So I'm drawing lines here from the center to center, symmetrical line, another symmetrical line, another symmetrical line. So the symmetrical lines are crossing each other at one common point, and that common point is the center of rotation. Now, there is one point which I'm drawing here, one symmetrical line. There's only one symmetrical line here. There's no other line is there, but that line is touching the center, which is at one point only. So that point is the center of rotation. That is nothing else. But if we'll be looking for the shape here, in this shape, you'll be looking that I'm drawing lines of symmetry here. One line of symmetry, second line of symmetry, third line of symmetry, fourth line of symmetry. So these all lines are passing through the center of the circle. So this is the center of rotation. Similarly, in this shape, we see that the lines are crossing from the symmetric line. One line of symmetry here and the second line of symmetry here. There are only two lines of symmetry possible. So these two lines are passing each other at one common point. So this common point is the center of rotation. But in this shape, we see that there is only one line of symmetry here. On one line of symmetry, there's no rotation, no line is possible for identifying the center of rotation. So we can't say about this one. Even we can't say about this shape that it has a line center of rotation. So we said that this is not a line of center of rotation. So because the line is rotating itself, yes, theoretically we can say that this may be the point here like that one. If I'll be repeating at one point, so it may have one point, and similarly this happens here. In this case, we may have one point. Now, for these types of shapes, if we'll be drawing one line of symmetry here, another line of symmetry here, and there are four different types of line of symmetry, but I say this eight different types of line of symmetry. These are the from the corners, from the triangles, and from the middle points. I'm drawing some other shapes here. Mm, these shapes I'm drawing with another colors to identify it differently. One point, second point, third point, fourth point. So these all are crossing with one central point. So that central point is the center of the rotational symmetry. Now this is done. Now it says the number of lines of symmetry. So we have seen that in this shape, there were four lines of symmetry. So we'll identify that there are four lines of symmetry. Order of rotation symmetry. So if we'll be rotating it differently, so how identify that this is making four lines of symmetry? So for this, I'll be doing one work here in Word file because it's not showing here. Now I'm rotating this now from this position. If we'll be saying that this is after 90 degree, it's showing the one time rotation. So its line of order of rotation symmetry is one now. So I'm drawing one. Now I'm rotating it further. So after rotating it further, I see that after rotating further 90 degree, there's one another shape which is crossing the same one. So I said that plus one another line of symmetry. Now if I say that now we need to rotate it further. So we are rotating it further now, and at this position we see that again the shape is the same. So order of rotation symmetry is again added up. Now we'll be going it further, and the red dot is on the red dot again. At this position, this is again the same shape. So I'll say that this is order of rotation symmetry is one more. So the total order of rotation symmetry of the square is 4. So this is the order of rotational symmetry. So order of rotation symmetry is that whenever we are rotating a shape up to 360 degree, then how many times it's repeating the same shape. So that number of shape which are repeating itself is the order of rotational symmetry. Okay. So now come to the again problem. So this that's why it has order of rotation symmetry of this is 4. Angle of rotation symmetry. So to calculate the angle of rotation symmetry, we'll be dividing 360 because we divided up we rotated up to 360 degree, dividing by 4 the order of rotation symmetry, which is 4. So we'll see that this gives us 90 degree. Similarly, come to the next one. It is giving us two types of shape which are the dividing it equally. But remember that in the rectangle, this diagonal line is not not a line of symmetry because this line on the other side, these lines are not making the same angle. Symmetry line are making the same angle and the same length on either side. So they are not making, so that's why diagonal is not a line of symmetry. So that's why diagonal will not be calculated here. So other than diagonals, what are the lines of symmetry? See that this is one line of symmetry, this is the second line of symmetry, so it has two lines of symmetry. Similarly, rectangular has order of rotation symmetry is also 2. So that is why the angle of rotation symmetry will be of 360 divided by 2, which is equal 180 degree. Now come to the third one. Its order of rotation symmetry and the line of symmetry is 3, and the order of rotation symmetry is also 3. So that's why the angle of rotation symmetry is 360 divided by 3, which gives us 120 degree. Now, this has only one line of symmetry, so that's why its order of rotation symmetry is also 1, and that is why 360 angle of rotation symmetry is 360 divided by 1, which is equal 360 degree. Now come to the circle. It has infinite line of symmetries. Infinite is represented by this symbol, or we can write in words that infinite line of symmetry. So if it has infinite line of symmetry, so the order of rotation symmetry is also infinite. If it has infinite line of symmetry, so the angle of rotation symmetry is, we can't define it, but approximately it leads up to 0 degree. Leads up to 0 degree, but not defined. Okay, but in this shape there are two lines of symmetry, so the order of rotation symmetry is also 2, and that is why 360 divided by 2 will give us the angle of rotation symmetry, which is of 180 degree. This has one line of symmetry, so the order of all line of symmetry is also 1, and the same happens here, that it will give us 360 divided by 1 is the angle of rotation symmetry is 360 degree. In this shape, if we'll be looking that it has 8 lines of symmetry, and similarly the order of rotation symmetry is also 8. That's why 360 divided by 8 will give us how much? So 45 degree. So this is the angle of rotation of this one shape. Now it says that is the given dotted line as line of symmetry. We see that left hand side and right hand side are not the same shape, so I'll say that no, this is not line of symmetry. Similarly, if we'll be looking for the above shape and below shape, so below shape is expanding and the above shape uh, is of the smaller shape. So these are not the same shapes. So that's why we say that no, this is not line of symmetry. But if we'll be looking for this shape here and C part, so we see that the left hand side shape is exactly the same as the right hand side shape. So these shapes are the same, so that's why this line of symmetry is yes, is a line of symmetry. Now if we'll be looking for this shape and the D parts, we see that this is the shape here on the same side, the same shape on the other side as well, same shape, but this is not mirror. In the mirror the shape must be look like that one, like that one, then it should be mirror like, but right now it's not mirror like, so this is not a line of symmetry. So remember that line of symmetry make a mirror image. Okay, now which of these shapes have the lowest order of rotation symmetry? We know that square has 4 order of rotation symmetry. Rhombus has 4 order of rotation symmetry. Four? No, sorry. Rhombus has, because rhombus is the compressed form of that square shape. So it will be giving us not the same shape, but it will be giving us 2 times the order of rotation symmetry, which I'm showing you here. If we'll be rotating this shape here again, so you see that this shape is not the same at 90 degree, but at this shape, this is 180 degree, it gives the same shape. Now at 270 degree, not same, but at 360 degree, it gives the same shape. So its order of rotation symmetry is 1 and then 2. So these are the lines of order of rotation symmetry, which is giving us 2 times shape the same in complete 360 degree rotation. One is at 180 degree and one is at 360 degree rotation. So that's why a rhombus has 2 order of rotation symmetry. And the rectangle also has 2 order of rotation symmetries. 2 kite has 1 order of rotation symmetry, and parallelogram also has a 1 line of order of rotation symmetry. So which of these draw and show it? So you can draw it and show it them as well. Now look for these shapes. I'm leaving this for you to draw these shapes and look for that how it is done by your own work. Okay. Now reflect the following shapes. Now for reflection, what we do, we'll be looking for the corners. Now what are the corners here? So if we'll be seeing the corner here, this is one corner of the shape, second corner and third corner. This corner from this from the line of symmetry is of one block distance. So the on the other side, one block distance will make the same dot. For dot 2, this was dot 1, this is dot 2, and this is dot 3. So dot 1 reflect the one dot, dot 2 reflect the dot of one block distance. So on the other side, one block distance, this is block 2. Block 3 is of 2 block distance from the line of symmetry. So that's 1, 2. At point 2, we'll be driving drop 3. And we'll be joining these lines, these points. So we'll get this shape. And we'll be filling out this with some, right? So this is the reflection. So this is how we draw a reflection. Similarly, the same happens with the other shape. So we'll be drawing dots on the corners, 1, 2, 3, and 4. One is 2 steps ahead away from this line of symmetry. So on the other side, 2 steps away from the line of symmetry, we draw one dot. And then 2 is away, 1, 2, and 3 lines of symmetry, 3 blocks from the line of symmetry. So 1, 2, 3 blocks from the line of symmetry, we'll draw a dot, which is 2. Similarly, 3 is of 1, 2, 3, 4, 4 blocks away from the line of symmetry. So we'll draw 1, 2, 3, 4, 4 blocks from the line of symmetry, which is of that point, which is 3. Similarly, for 4, 1, 2, 3. So 1, 2, 3, this is a point 4. So we'll be joining these points 1, 2, 3, 4, and then we'll be filling out with the shade, and this is the reflection of that shape which we see here. Okay. Similarly, this is our line of symmetry. We see here is the line of symmetry here. Okay. And from this line of symmetry, we'll look for the dots. One dot, second dot, third dot, and fourth dot. So we'll be looking at how much distance it has from this line of symmetry. 2 dots, 2 blocks, so 2 blocks. This is 1. Okay. And then the second one is 1, 2, 3, 4. So 1, 2, 3, 4. So this is a 2. And then the rest one will be looking for the shape is dot 3. So the dot 3 is also 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So this is a block 3. And then we'll be looking for 4. 4 is actually how many blocks away from this one? So this is a 4 is actually a 1, 2, 3. So 1, 2, 3. This is a block 4. And now I'm erasing the lines, the distance line here. Now I'll be joining these points 1, 2, 3, 4, and that is the shape which will refill to make the reflection of the previous shape. So this is how we can draw these shapes. Again, if we'll be looking for this type of shape, this corner here again, we'll be noting down the corner, one corner, second corner, third corner, fourth corner, fifth, sixth, and seventh. So one corner is one block away. So one block away, there is a point we are drawing. One. Then two is two blocks away. So two blocks away, there's a point two. Three is two blocks away. So three blocks away from there's three. And there is four is actually one, two, three, four, 5 blocks away. So we'll be drawing one, 2, 3, 4, 5 blocks away, which is here. And similarly, 5 is also here. And then 6 is 1, 2 blocks away, so 2 blocks away here. And the 7 is 2 blocks away, so 2 blocks away is here. This is 7, and that's it. So we are joining these all the points 1, 2, 3, 4, 5, 6, 7, and then again 1. Now we are filling this, and this filling gives us the complete reflection of the original shape. So this is how we draw the reflection. But somehow we have some other shapes which are like that, these types of shapes. It says that the reflection across the y is equal to 2. So how we draw y is equal to 2? First of all, we need to know what is y is equal to 2. So y is equal to 2 is a line which is on y-axis, and I'm drawing y is equal to 2 here. This is a line which is called y is equal to 2. Now where the dot is? Dot is here on the top. You can see here point A. This is a dot. So dot is 2 blocks away from the line of symmetry. So on the other side, 2 blocks away, there will be another point, which is A prime, which is the reflection of A. So this is how we draw it. Similarly, on the second one, it says reflection across y-axis. Where the y-axis is? Y-axis is this line, which is the vertical line, y-axis. This is y-axis. This y-axis. On the y-axis, where the point is, point on the right-hand side, which is called M, which is how many blocks away? 1, 2, and 3 blocks away. So from left-hand side, we'll be making 3 blocks, 1, 2, and 3, and then we'll be pointing out the dot, which is now the point, which is now M prime. So M prime is the answer of this M. This is the reflection. Now come to the next one. It says x is equal minus 1. So from x is equal to minus 1 on x-axis at point minus 1, we'll be drawing a vertical line. So this vertical line is actually x is equal -1, and at this point we'll be looking where the point is. So on the left hand side you see that there is a point S. So this point is 1, 2, 3 blocks away from the line of symmetry. So on the right hand side, we'll be making 3 blocks, 1, 2, and 3, and then we'll draw a dot here and we'll name it as S prime. This is the answer. This is the reflection. Now it says that y is equal -3. So on y-axis, we'll be drawing -8 line at -3. So this is a -3. So we'll be drawing a line here at -3. This is y is equal -3. And now we'll be looking for the point. Point is above the line, which is K, which is 1, 2, 3, 4 points away. So on the other side, we'll be drawing 4 points away. 1, 2, 3, 4. And this is the point which is called K, may be called as K prime, the reflection of K. Now the reflection along the y is equal x. So what is the line y is equal to x? This is the line where x value and y values are equal. So this is actually the diagonal line. So diagonal line is the line where the x value and y's values are always equal. Now in this point, now we'll be looking for the point that is here. Now, to reach this point, because now line is diagonal, so what we do, we'll be going horizontally or vertically. If we are going vertically to reach the point 1, 2, 3, 4, 5, 6, 7, then we'll be going horizontally 1, 2, 3, 4, 5, 6, 7. So this is a point where we can reach as n prime. There's one way. Another way is that if we are rather than going vertically, we are going horizontally first. So we'll be reaching the line, vertical imaginary line, which is the line of symmetry. So 1, 2, 3, 4, 5, 6, and 7. The 7 steps are required horizontally. So vertically we'll be going 7 steps up then. 1, 2, 3, 4, 5, 6, and 7. So this is a point which is called n prime. Okay. So like this we can draw a line like that. Okay. Now there is x is equal to 4 and x is equal to 3 and y is equal to -5. I'm leaving these points for you to do a practice of it. Now there are the points for each shape. Write down its order of rotation symmetry. We have done about rectangle. Its order of rotation symmetry was 2. Order of rotational symmetry of a square was 4, and it has an arrow on one side, so its order of rotational symmetry is 1. But for these types of shape, this is a circle, but there are lines on it, so it is not making it unique shape. So that's why its order of rotational symmetry is 1. But for these types of shape, you see that it has an arrow on all the sides. So we'll be looking for the same type of arrow. We see that there are same type of arrow on each side. So how many arrows are there? 1, 2, 3, 4, 5, 6, 7, and 8. So its order of rotation symmetry will also be 8. So its order of rotation symmetry of this star is 8. Now this is because this was a regular shape and it has 8 arrows. So now it is a regular equilateral triangle. It has 3 shapes, so its order of rotation symmetry is also 3. Okay. This is a regular dumbbell, and then we can see that that is reflecting its shape on 2 sides. So that's why its order of rotation symmetry is 2. And this is an alphabet A, which has only one side, so its order of rotation symmetry is also 1. But in fans, we can see that there are three sides, the same one, 2, and 3. So that's why its order of rotation symmetry is 3. So like this, you can identify and check out the order of rotation symmetry. And I'm sending these pages for you to practice on these and look for these shapes. I'm sending you these shapes and then take a picture of it and then practice this and tell me what you have done. If you do not understand, do let me know. There's one shape here and another shape is here and another shape is here. This is about reflection. So go for these questions and there is one more. No more questions, just teasing you. And then you have to practice it and do tell me if you need any guideline required or any more explanation required, you can ask me. Thank you. See you next time. Allah Hafiz.